intercept form is y equals mx plus b. Now let's talk about this, what these m, what this x, what the b, and what the y means. First off, I think the easiest one is, what does the b stand for? The y-intercept. Absolutely. The b stands for where that line crosses the y-intercept. So like if we had a graph over to the side, and we had a line going here, that point is the y-intercept. Where it crosses the y-intercept. Okay, that's what B stands for. Now, what does the M stand for? What's the M stand for? No. What's the M stand for? Slope. Whatever that slope is, that's what that M stands for. So your slope always comes first, then you have your X, then you have your B. Okay, let's talk about the X and Y. Well, that's pretty simple. X and Y just stand for the X and Y values. Like if you had a coordinate for X and Y, that's what that is. So your X value would be substituted in for X, and your Y value would be substituted in for Y. That's just your X and Y coordinate. Okay? Now, there's one thing I want you to make sure you recognize is, it's always, always, always solved for Y. Okay? No matter what you do to get it into this form, you need to solve it for Y. Always, always, always solve it for Y. Okay, that's how you get it into slope-intercept form. All right, does that make sense? Okay, let's say if we have these two problems. Make sure you have them written down. And I say, I want you to put both of these in slope-intercept form. Now, what's it going to start out with? Let's talk about the first one. What does slope-intercept start out with? What's the first thing you see? A y. Okay. What's the next thing you see? N equals. What's the slope? Negative 2 over 7. That's pretty simple. Just write negative 2 over 7. That's all you're doing. That's all I want you to do right now. So it's always y equals. Your slope always comes first. What comes next? X. We're on a roll. Now, for my y-intercept, my number's 4. Am I just going to write down 4? Is that the only thing I write down? Not everybody at once. That's a period. Plus 4. Whatever that sign is of that y-intercept, that's what you're going to insert. So for number 1, it's a positive 4. That's a y-intercept of a positive 4. So just write plus 4. That's it. Okay, for number 2. It's going to start out with a y equals. I have a slope of 7. Okay? So what am I going to write down? 7. Now, in terms of slope, in terms of rise over run, what is that really? 7 over 1. Like if I was looking at a graph, or if I wanted to graph this out, I would go up 7 and over 1. Okay? Make sure you understand that. All right? Now, you can leave it as 7 over 1, or you can leave it as 7. It does not matter. both of them mean the exact same thing. Okay, what's going to come next? Well, I'm going to have an x. And in this case, my y-intercept is a minus 4. Well, I'm just going to have minus 4. Okay? And you're done. So we're going to go ahead and sketch these out. Okay, so for number 1, the first thing that you should always do when graphing an equation that's in slope-intercept form is what? Any suggestions? Do we start with the slope? Do we start with an x? Start with a y? What? What do we start out with? What's the first thing we plot? What's the first thing we do? Perfect. Y-intercept. What's my y-intercept? Not everybody wants. Positive 4. So I would start, essentially, I'm going to start here. Okay, always start at the origin, the middle. And if my y-intercept is positive 4, well, I'm just going to go up 4. So up 1, 2, 3, 4. And I'm going to plot that point. Okay? Now remember, your graph does not have to be perfect. That's not what I'm after. Okay? So that's the very first thing that you do. Next up, this is when we plot our slope. Now, our slope is a negative number, and it's a 2 over 7. So what am I going to do? Am I going to go diagonal 2, crisscross 7? Well, in terms of the first thing you should always do when plotting a slope is either you're going to rise or you're going to go down. Either up or down first. In this case, this is a negative slope. So we're going to go down. So our first thing is we're going to go down 2. So we're going to go ahead and move down 2. So down 1 and then down 2. That's the first thing that you do. Now, the run part is what? How much am I going over? 7. So you're going to go over 7. So over 1, 2, 3, 4, 5, 6. One more line. Okay? And then you would plot that point. Make sure you're going down 2, then over 7. We have a negative slope, so we're going to go down. So the first thing you should do is go down 2, then over 7. If you feel comfortable doing this, you can go ahead and plot out number 2. Okay? If not, follow along with me. Make sure you go down 2. Here's a little higher up. Well, you do go down 2, I'm sorry. Now, the last thing you would do in terms of graphing this thing is you would just make your line. And you'd be done. Okay? So the last thing you would do, you just graph out that line. So, remember, the first thing we're going to do is graph out the y-intercept. Now, this is a minus 4. What am I going to do? Am I going to go left 4? Right 4? Diagonal 4? A circular 4? If it's a negative, which in this case, yes, good, thank you. We're going to go down 4. So we go down 1, 2, 3, 4. And we plot that point right there. Okay. So down 4 and we plot that point. Now, what's my slope? 7 over 1. So am I going to go over 7, up 1, or what? Always go. Yeah, that top number tells you how much to either rise or go down. In this case, where it's a positive, so we're going to go up. And Dakota's exactly right. We're going to go up 7. Okay? So we're going to go up 7, and eventually we're going to go over 1, absolutely. So we'd go up 7, 1, 2, 3, 4, 5, 6, 7. Okay. And the last part is, I think Amanda said it, we're going to go over 1. So you'd go over 1, and you'd plot that point. Okay. So up 7, 1, 2, 3, 4, 5, 6, 7, over 1. And the last thing you would do is connect your dots. That's a very steep graph. Why is it a very steep graph? You know why? Yes. Okay. So this second one, that's a -2. The y-intercept is a -2. Do you see that, Noah? So you can just write, instead of doing plus a -2, all you really need to do is just -2. You see the difference there. That is a very common, it's not really a mistake, but it'll make that look really, really weird. You get what I'm saying? So it's just so much easier, just put a -2. If you did do the plus -2, you would have to, like Freddie said, put that in parentheses. Okay? Good point. I'm glad you put that up. Okay, for the first one, Dakota Smith, talk me through graphing it. So what's the first thing I'm going to do for number 1? Okay, so I'm going to go up, down, left, right. Up 4 from that middle, so up 4, and you plot that point. Okay, Dakota, what's the next thing I'm going to do? Other Dakota. I'm going to go, so what is my slope? Dakota? -2. So am I just going to go down 2 and then be done with it? In terms of graphing, what is that really? What is that -2 really? In terms of actually graphing it? It's a -2 over 1. Okay, do you guys see that? So in terms of graphing, it's really -2 over 1. So yeah, Dakota, you're right. So we're going to go down 2 and then over what? Over 1. Now my graph is a little not very too close right there on the ones, but that's okay. And then the last thing we're going to do, we're going to connect those dots. Okay, and your graph will look something like that. Victoria, talk to me, what's the first step for number 2? What's the first thing I'm going to do? Yep. I think you're on the right track. Yeah. You said subtract 2? Yeah. So in terms of graphing it, what am I going to do? Am I going to start from this middle and go left or right or up or what? If that's a -2, you have to go down first. So that negative is telling me to go start here and go down, and that number is 2. So I'm going to go down 2 and I'm going to plot that point. Davis, what's the next thing I'm going to do? Absolutely. Now I'm going to work with my slope. And Davis is perfectly right. I'm going to go up 4 and I'm going to go over 3. So up 4, 1, 2, 3, 4, and over 3, 1, 2, 3. Plot that point. And the last thing I would do is connect the dots. What is the equation for this? Well, what's the first thing you should probably look at? The y-intercept. What is the y-intercept in this case? 2. So I know at the very end I'm going to have a 2. What's the next? What else can I go ahead and plug in? Well, I'm sorry. Is that a positive 2? Yeah. So put a plus sign in front of it. Yes, Amanda. What else can I do? Okay. What's the slope? Yeah, my drawing's a little bit skewed, I guess. So. Not 1/2. But what, JT? It's 2 over 1, but you're still missing one thing. Negative. Good. Good. In this case, look at, you start at your y-intercept, and you just go and find the next point. Okay? So you wouldn't go down 1 and then kind of guess, oh, that's down 1 over 1 half. Like, you wouldn't go here, okay, and try to plot that point. You would go down 1, 2, and I would go over 1. So my slope is really a negative 2. Okay? So that's the next thing I would fill in. What's good? What's always beside of the slope? It's always beside of the slope. X. What's the last thing we need to do? Y equals. That's it. Now, you're right in terms of graphing, that's really negative 2 over 1. Okay, remember, that's all. You can always, if it's a whole number like negative 2, 4, 5, 10, 8, 9, 10, 11, 12, 13, 14, 15, you can always put it over 1. Okay, if it's a fraction like 3 over 2, 6 over 8, 9 over 10, that's already essentially in a way that you can graph it out easier. Okay? So recognize that. I want to graph out these two equations of a line. Okay, sorry. Okay, so we want to graph these two equations out. Now, there are some times in which you need to get whatever these equations are into slope-intercept form. Now, in terms of slope-intercept form, what does it always solve? Like, what is it always equal to? What is it? Well, it's always y equals mx plus b. So we always need y equals. Okay? So let's say if I wanted to get both of these equations into slope-intercept form. What would I have to do for each one of these? Absolutely, which means that for each one of these, we need to get y by itself. We need to get it in y equals whatever, the slope and the y-intercept. Okay? So, for number 1, if I wanted the y by itself, if I want to solve for y, well, if I want this y all by itself over here, what would I have to do to get rid of this negative 3x? Would I divide both sides by negative 3? Yes, no, maybe so. What? No, you would not be dividing by 3 for both sides. I want to get this whole term, this whole negative 3x to this other side. So instead of like dividing by negative 3, all I'm going to do is, instead, this is a negative 3x, I'm going to add 3x to both sides. Does everybody see that? Because that is very, very, very confusing to some people. Okay? I would have to add 3x to both sides, not divide both sides by negative 3. Now, by doing that, what happens to that negative 3x on the left side over here? It cancels. So you can draw a little line through that. That's gone. So what do I have left? Well, I have a y equals. Now, would I write 6 plus 3x? Is that considered slope-intercept form? No. Okay? So you can write it like that, then you can flip it, or you can just think of it as it's a positive 3x. So really, this is really y equals, that's a positive 3x. So I'm going to write down a positive 3x. That's a positive 6. So I'm going to write down plus 6. Okay? Both sides. Okay? I'm not going to divide both sides by negative 5. Remember, you want y by itself. So we just talked about we're going to add 5x to both sides because that's a negative 5x. I'm going to add 5x to both sides. Okay? So what's going to happen to this left side? Well, it's going to cancel out. What am I going to have left? Well, I'm going to have a y equals, I have a positive 5x, so write down 5x, and I have a positive 1, plus 1. Thank you. And you're done. Always going to solve for y. So for this number 3, what's the first thing I can do? What's probably in terms of solving or solving for an equation, you wouldn't divide both sides by 3 first. You would always add or subtract first. So this is a minus 6. How do I get it over to this side? I'm going to add 6 to both sides. Okay? Now, what am I going to have left? Well, on the left side, I'm going to have 3y. Okay, that just comes down. I have a 2x plus 6. So 2x plus 6. Okay. What's the last thing I'm going to do here, Freddie? Perfect. Now in this case, we are going to divide, okay, because all we have left on that left side is just the 3y. So how do I get the y by itself? Well, it's being multiplied by 3, so I need to do the opposite. Always do the opposite. So I'm going to divide both sides by 3. Now, when I divide both sides by 3, this is very important. Do I just divide the 2 by the 3? No, I divide that whole side by 3. Okay? I divide each number by 3. Now you can write it as that, or you can think about, okay, I know I'm going to divide 2 by 3, then I'm also going to divide 6 by 3. Divide all those numbers by 3. Whichever way you want to write it, that's okay. Okay? And all I'm going to have left is, first off, it's going to cancel that left side. For my right side, I'm going to have, can I simplify 2 over 3? No. What about the 6 over 3? Yes, I can simplify that to 2. And you're done. Dakota. Good. We're going to minus 4x on both sides. Okay? That's a positive 4x. Let's minus 4x from both sides. All I'm going to have left is a 9y is equal to a negative 4x plus 27. Okay? We are almost done. How do I get y by itself now? Noah. Oh, not 9y. Absolutely. Perfect. We're just going to divide 9 from both sides. So that number by 9 and that number by 9. That cancels that left side out. Now all we have left is a y equals negative 4 over 9x. Now 27 divided by 9. Can we simplify that? Absolutely. Plus 3.